in minutes here, so that's got to be immense.
Yeah, it's massive, and the students take all this. They this at the core of this competition. It's a STEM education competition in my book, and it's amazing to see what the students will do and the work ethic that they have, and of course led by their faculty advisors. And it looks like we have the first car rolling out onto the track here. IU-Luddy.
If you haven't seen this, folks, this is something else. Really, really fun to watch. And what really opened my eyes up as this car heads up, I've done a lot of motorsports announcing and, race announcing with drivers. And I could tell, there's the human connection because this is all done with the coding and making sure everything works. The moment, ironically, the light bulb went on for me was when the lights went out at Las Vegas Motor Speedway, and 3 of the teams went out and at about 100 miles an hour average, lapped in the absolute pitch black.
Yeah, they make it look kind of easy. The cars can run in the dark. Obviously, between the GPS and the lidars, they can see through that, and the radars, they have no issue in the dark. If it were to rain today, we probably wouldn't run in the rain. That's really just to save the cars.
Yeah,
that's a really difficult challenge, but yeah, they're doing everything by themselves.
Well, any high-speed race car is not a cheap thing to start with, but then with everything that Clemson has done and all your partners have done, what's the rough cost, would you say, of one of these?
These cars are around $1 million, and so
there you go.
It's a lot for some students to have on their shoulders as they're running, and so you'll see that today they'll be a little bit nervous about pushing if they're not exactly sure that the car is going to do well. The one thing I give a lot of credit to Dallara for, though, is that these vehicles are relatively easy to repair. Right, they're a common race car. If there's a major issue, they can get them usually back and going overnight. So they are set up for that. And so generally you don't have a crash big enough where you're going to write off the whole vehicle.
And the run officially starts, right, when they come around now after being released out of the pits, when they cross the famous yard of bricks, that's when the run starts.
That's right. And IU-Luddy here, they'll have 5 minutes to put in their lap time from the time they hit the stripe here, the famous yard of bricks, as you mentioned, till when they have to complete their final lap. They have 5 minutes to set the fastest time that they can on average.
All right.
And you can see that they're heading down the famous front straightaway here.
Yep.
This is again all by this is the computer doing this. The race control would have started the vehicle off and gave it the commands that it was safe to fire up the engine when the pit road was clear. The vehicle pulls out of its own pit stall and takes off. As you see this one heading into turn 1. One of the things you can see there, they're kind of high on a high line there. They're not right down on that white line because they're probably a little bit nervous. The traditional racing line would be to start really far outside by the wall, come right down to that white line in the middle of the corner, and then work your way right back out to that wall again on the exit of turn 2 here. The challenge is that if you're not super certain that your car will hold that line very well, or you're exactly certain where your car is at any given time, you'll give a little bit more of a buffer there, and that's what you can see with this vehicle. And luckily, they're going quite well, but it's the car has enough traction until you get to about 150 miles an hour or so in those corners that you really have to start worrying about having that exact line so that you can make sure you hold traction as you're going.
Yeah, and the car's sliding a little bit and doing all of that.
Yeah.
And so what you're basically saying here with that is a driver in the car might be more brave, but the hardware stack and the software has probably got a lot more common sense.
Well, yeah, you can probably say it that way. They're heading right now. They're at 113 miles an hour out on the track, so they're really getting after it. Obviously, way above highway speeds, and so this is a pretty impressive run. When we started here a few years ago, this is about as fast as you'd see anybody run as they go by us here on the front straightaway.
And this is one of the newer teams in the program, isn't it?
Yeah, they've really been only going at it for a little while, so it's quite impressive to see them out here and running laps like this, and their car looks very stable. One of the challenges you'll see maybe some of the later vehicles as they get to a little bit higher speed is that the steering control can be a little bit scary looking, especially on the exit of some of the corners. You see the cars move around a little bit. Yeah. And that's the steering controller trying to make sure that the vehicle is actually going straight. But this car looks very smooth. They're doing a great job.
And all of that's done, drive or fly-by-wire, isn't it? With servos and the like.
Yeah, that's right. There's an electric motor that drives the traditional steering rack that you'd see in the vehicle, and then there are a couple different actuators that control the brakes, and the one actuator that controls the front brakes and one that controls the rear brakes, so the teams can actually adjust the brake bias, we call it, so how much front to rear braking that they have on the vehicle. And then the throttle to the engine is also electronic, and the gear shifting is done automatically. When the team asks for a gear, the engine controller will automatically, what we call blip the throttle to make sure that the gear shift is automated in that way.
just curious here. Obviously, we saw when IU-Luddy went out here, the car was on what you would call stickers, a brand new set of tires. Do they? Ooh, that's a 10-mile-an-hour jump in their second lap,
That's right.
folks. That's impressive. We are now at 121.052, and that is miles per hour. That is moving right along here, and very, very impressive. What I was going to ask was, is there any programming built in where we see him doing what, say, a driver would do, which is scrubbing to try and get heat in the tires?
You'll see that. Actually, you can see them doing that here. They generally don't do the scrubbing that you'd normally see, but they're slowly working their way up to higher and higher speed as the tires warm up. The vehicles have tire pressure and temperature sensors in them. They scan the inside tread of each tire, I think, in 8 places, and so they can see, hey, as the tires ramp up, and their control algorithm will see that as well. As the tire temperatures come up, I can go to a little bit higher speed. If you're new to racing, cold tires are one of your biggest enemies, and so you really want to make sure that they get them up to temperature, and they become incredibly they get incredibly high traction at that point. And so you can see they just run it through the corner here at 127 miles an hour or so through turn 4.
We're going to see what this third lap is going to be looking like here. A 10-mile-an-hour jump, lap 1 to lap 2. Will they match that or better it even here? They've come across the yard of bricks. Another 3-mile-an-hour jump.
And you can see the car as it came off of turn 4 there, it was kind of hunting around for a straight line. And you can see that, so they're probably getting about to the limit where I would guess they're going to probably shut it down here and think, okay, I'm about done. And it looks like maybe they have come down on the pace a little bit here. So that looks like that's going to be their fastest lap time there, 124, which is outstanding. Right?
That's impressive. And again, when we talk about one of the newer teams in this whole operation here, to be up and approaching 125 miles an hour as an average speed, that's saying something.
Yeah, absolutely. They did a great job. Their students should be really proud of what they've done over the last few weeks, and to get this vehicle up and going at this speed, it's outstanding to see them do this.
Yeah, and for those of you watching that may not have a lot of racing experience, one of the reasons it's so important to get the tires warmed up is that there are 2 things that generate grip, if you will. One is tire temperature. And when you've got to get the tires up to a certain temp where the rubber gets grippy on it. The other thing is the temperature of the tire, and there's a happy group. The temperature of the tire dictates the pressure inside the tire, and the pressure inside the tire oftentimes dictates the handling of the car via the setup, and that's where you get grip.
That's right. Yeah, the teams have great models of all of that. They have all this data on the vehicle, and so they have gone through, as I've said, thousands of miles of testing, and they continually refine their models. They have advanced instrumentation on the vehicle to measure things like slip angle, so they can develop their own estimation algorithms, we call them, to determine, okay, how much traction we're going to have when I go in this corner at this speed, and do I need to speed up or slow down, and their controllers will do all that. You can see the vehicle autonomously going into the pits, and the Purdue AI racing team should be already headed now out on the back straightaway for their run.
Wow. How about that, though, folks? Almost 125 miles an hour from our first car out, one of the newer ones in the program, IU-Luddy. Absolutely superb kickoff here, again, to the time trial section. And the top people in the time trial section will go into the passing competition. That's a little bit later on. But even this time trial part of it has their own rewards and awards because if you're quickest car out there, that's pretty impressive.
Oh, absolutely. And all of the teams that you'll see here on the time trial, all of them that are eligible to run could get out there and run. In the passing competition, there was actually a more stringent qualification process. So you actually only see 6 teams involved in that later, assuming they all make it through these high-speed runs. I know a lot of these teams are really interested in going in winning this section of the competition for the bragging rights for sure. And there's also some prize money on the line for that. So we'll see that they all make it through to live another day. And it's one of the interesting things about racing is if you want to win, you